Hello everybody. Okay, so this is for my XP. I'm doing Module 10, Chapter 19, Exercise 12. So I'm going to read the question out loud. Which test again? For each of the following situations, state whether you'd use a chi-square goodness of fit test, chi-square test of homogeneity, or a chi-square test of independence, or some other statistical test. So before answering this question, I feel like I have to inform you guys of the different tests. So I decided to take the books, I decided to take the definitions right out of the book so I knew it was right. So for the chi-square goodness of fit, this can be found on page 630. This is what it says. A test of whether the distribution of counts in one categorical variable matches the distribution predicted by a model is called a test of goodness of fit. In a chi-square goodness of fit test, the expected counts come from the predicting model. The test finds a p-value from the chi-square model with n-1 degrees of freedom, where n is the number of categories in the categorical variable. So the next one is the chi-square test of homogeneity. A test comparing the distribution of counts for two or more groups on the same categorical variable. A chi-square test of homogeneity finds the expected counts based on the overall frequency, adjusted for the totals in each group under the null hypothesis assumption that the distributions are the same in each group. We find a p-value from a chi-square distribution with rows minus 1 times columns minus 1. Degrees of freedom, where rows give the number of categories and columns give the number of independent groups. For the last one, it's chi-square test of independence, and these two are very similar. Test of whether two categorical variables are independent examines the distribution of counts for one group of individuals classified according to both variables. A chi-square test of independence finds expected counts by assuming that knowing the marginal totals tell us the cell frequencies. Assuming that there is no association between the variables, this turns out to be the same calculation done as homogeneity. We find a p-value from a chi-square test distribution with rows minus 1 times columns minus 1 degrees of freedom, where rows give the number of categories in one variable and columns give the number of categories in the other. Okay, so after figuring out all of the definitions, I'm going to now start with A. Is the quality of a car affected by what day it was built? A car manufacturer examines a random sample of the warranty claims filled over the past 2 years to test whether defects are randomly distributed across days of the work week. So for A, I actually put the test of independence, and here is why. So here we are trying to see if the random sample of the warranty claims filled over the past 2 years, whether defects are randomly distributed across days of the work week. So if it does, that means that they are not independent. So if they do affect each other, that means they are not independent, because the independent definition means one does not affect the other. So this is basically seeing, are they independent or not? And also in the independent, so yeah, it's examining the distribution of counts for one group of individuals classified according to both variables. So this one is just trying to see if the quality of car is affected by what day it was built, all of that. So that is why I chose the independent, just because it is trying to see if they are independent of each other. And if they're not independent of each other, then it does not pass this test. So B, a medical researcher wants to know if blood cholesterol level is related to heart disease. She examines a database of 10,000 patients, testing whether the cholesterol level in milligrams is related to whether or not a person has heart disease. So for me, I said the chi-square test of homogeneity, because this is a test comparing the distribution of counts for two or more groups on the same categorical variable. So basically, it wants to know if blood cholesterol level is related to heart disease. It's comparing the two, so it's comparing two or more of the groups on the same categorical variable. It's comparing two of them. So yeah, I just decided, just because it's not seeing if they're independent or not, it is just comparing if they are the same, if that makes sense, because they are in the same categorical variable. So yeah, that is why I chose the test of homogeneity. To me, it is still, I mean, let me know, whoever's watching this, if you have a good way of figuring out a different way to distinguish the chi-square test of homogeneity and the chi-square test of independence. I just still get a little bit tripped up on both of those because to me they're pretty similar. But anyways, the last one, C. A student wants to find out whether political leaning, liberal, moderate, or conservative is related to choice of major. He surveys 500 randomly chosen students and performs a test. So I chose this to be the chi-square goodness of fit test. This is all in one categorical variable, matches the distribution predicted in model called goodness of fit. So this student wants to find out whether the political leaning for his specific major, so it's basically comparing three things to one thing. So that's why I decided to use the chi-square goodness of fit test, because the test is whether the distribution in one categorical variable matches the distribution predicted by a model, because we're predicting and seeing the political views and then seeing just how it affects his major specifically. So that is why I decided to do the chi-square goodness of fit test. Let me know if anybody thought any other ones specifically. That is my best estimate for all of them. Thank you.